Hi there, I'm Daniel Markham, and welcome back to EasyAM. I think this is episode 4. If you just joined us, EasyAM is the world's first analysis compiler. Basically, if you know what domain modeling is, I wrote the domain model for domain modeling. EasyAM is the executable version of that model. That's sort of a fancy way of saying, if you don't know what a domain model is, it's a fancy way of saying, I made an easy to do way of taking notes. No matter how many notes you have, the notes go through a compiler, and then the compiler organizes the notes for stuff like user stories, tests, different things you would need. So it's a universal sort of project information system based around tagging and compiling. That's kind of where we're here. There's a wiki site on that, a bunch of places to go. There's a spec, this is a book, there's a bunch of stuff there. We're on episode 4, and this is the version 3 of the compiler. And to do version 3, version 1 I sort of roughed it out for teaching class. Version 2 is already on GitHub, runs fine. It's used in the book. In version 3, I thought I'd take F#, which is my favorite language, and go back and rewrite the compiler as an example of how to write F# code using emerging incremental type development, as opposed to maybe domain-driven development or some other ways you may do F# coding. Okay, so that's kind of why we're here. I guess that's the boring part. I don't know if that's the boring part or not. I hope that is the boring part. Let's take a look at the stories we had. Humbity, where are my stories? That's not my stories. Hang on. I don't know. Maybe it's here. So the stories I had the time before last was, I think, just process empty files. And we did a video. There's a 20-minute video. The two rules I had was only 20-minute videos, because I figured you guys would get bored after 20 minutes. And they would represent about 3 hours of work each. That way it would be fair. I wouldn't spend weeks at a time and only give you like 5, as if it were magic or something. I broke all those rules this time. Spent about 2 weeks doing this stuff, and I'm going to do probably 40 or 45 minutes. I'm going to break it into 3 chunks. Chunk 1 will be, I'll talk about kind of what happened last time. Chunk 2, we'll talk about the development afterwards, and in chunk 3, we'll talk about kind of where this is going. So where we were was we were doing some empty files, and I showed you that it worked, and the batch file that did the testing actually was having some problems. I went, well, there's some problems with the batch file. I'll look at that after we're done. And of course I did. And what I realized right away was that it was broken. And the reason it was broken was because of that stupid console problem. .NET programs, of course, all programs have to have standard in, standard out, standard error. And Unix has a solved problem for years, but when .NET folks put together like they want to do, they did it their own way, which was fine too, because streams are good, and it's actually a better way. So many times this is the case. But then clients who used Windows would do things like open a stream and then never let it go. And so basically you're stuck in this position where if you run a .NET app, even if it's in a Linux environment, sometimes they never stop talking to you, even if they have nothing to say. This is sort of like a salesman. So to fix that, you got to do some hacking. I love good, solid, testable code, and I love programming. I love helping people solve problems big time. But if you haven't hacked, you're really, in my mind, you're not a coder. So by hacking, I mean doing something in an odd or some weird way that works and fixes the problem in a way that couldn't have been done otherwise. So let's go to program.fs. This is all on GitHub. You're welcome to follow along. So you can see I put a bunch of comments in. The way to fix this, I found one person on the internet that had this fixed. It was a C# guy, Dave Glick, I think. And oh my gosh, C# code full of threads. I'm like, why do you have to have threads? Why does it have to be so complicated? And then I looked at it and I played with it. I tried to take each little piece apart to make it a simple spot. No, this is all got to be in here. I put comments in why. So basically you've got a flood manager and a flood worker, and the flood manager right here just sort of spins up a bunch of flood workers, And the flood workers just go, hey, you got anything to tell me? Hey, you got anything to tell me? Hey, you got anything to tell me? Hey, just over blah, 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 until I'm sorry, what is it? Until there's an end of stream. I think there's a 5-second time limit. Like I said, it's been 3 weeks since I coded. It's a 5-second time limit. It quits, but it doesn't send the threads away to come back. It just, because otherwise the communications get to be an issue, and it's just hammering the Win32 consoles. Ready? You got anything now? Anything now? So finally, I guess the console gives up whatever it's got coming in, and for one of these lucky threads, all the data comes in, and they save it. And this happens right in here about line 38 or so. I reserve a 64K buffer initially, and then whenever I find the thread that's getting stuff, then they'll do the loop here to see if there's any more stuff, and then it'll keep pulling the stream in. So you throw out all these threads with a 5-second time limit for the whole thing, just as many as you can throw out in 5 seconds, and we're done at the end, no matter what. So where does the data go? Which is threading. Reasoning about threading is not a trivial matter. The .NET library helps a lot. The F# library especially so. As you move to pure programming, it becomes less and less of an issue because you're sort of transmitting your data and your code at the same time, and who cares where it runs or how it runs? It all comes back when you assemble it. So for this, I couldn't do it because I wasn't really doing pure programming because I didn't know if it was coming back, and ended up having to put a buffer to handle input being piped through the command. So I have a module level buffer that actually gets stuffed, and then we pull the rest of the stuff in. There's some mutable stuff going on here. The buffer and the read size. Why couldn't I pull that out and just tried to, didn't work. It's in the comments if you're interested. It was a hoot. This is non-standard, non-obvious code. I hate writing this for production work, but man, it is what it is. This is exactly the kind of stuff you would want to pull away into a library or something, so you'd never have to look at it again. That's probably what I'll do once I test it thoroughly with several different applications. Okay, so that was the fun. That was the streaming thing, and then I rerun my bash tests. I actually tweaked them a little bit. They're looking most awesome. I will show them to you at the end of this episode. I won't show you now because I've updated the code. What else do we have? So that's the stories. I was going to tell you this. So stories for this upcoming little chunk we're doing. I've already done the empty file and repeat back to me and stick the two files together thing. Now we're going to do recognize and sort lines by line type and print out project to do items. So now it's going to go through, and by the way, the notes you see here, these user stories, not only these notes for us, this is actually the input for the compiler, so works both ways. It's a floor racks and a dessert topping. So here we have two user stories, and I have parents for the user stories. If you're interested in how this is sort of going to come about, I'll show you a larger, this was kind of when you came in. This is a model I'm filling out as I actually implement features. And so we have I'm not going to do the book for you, but we've got the high level stuff. I've got some supplementals. You guys may think of those as non-functionals or constraints. Here's some supplementals. I've got the reasoning for those. I've got dead batteries here. I've got some business abstract behavior, which would be my master user stories, master backlog. And then for a user story, I actually sort of start tagging those by the episode, the status, and so forth. And as we fill out the compiler, we'll show how we can keep track of burn down, however you want to, whatever meta stuff you want to add around your project information notes. It'll compile it and send it out to spreadsheets and do things like that. This is different than the usual sort of build a PM tool that's got forms you fill out or drag stuff around. This is a tag compile thing, so if you don't have things to put in, you just type in some notes, we're good. If you want to do 40,000 lines of stuff and have it all compiled together and have it linked together all your online systems, we're still good. It's the same compiler either way. So our stories, this is what it looks like, and our stories coming up are going to be just sort of print and sort here. And I didn't know what print meant until I started working on it. And if you're in a team, you talk with the product owner. Of course, I am the product owner. One of the things I want to go over with you today is the thing that, where am I here? There we go. I did this. This is my to-do list for the video. Be sure to talk about the compiler as a solo dev. Some of the stuff you're going to see here, all the comments, the verbose stuff. I am the solo developer and the product owner for this app. It means I can do some stuff I normally wouldn't do, like ask myself questions in the code, tell jokes. If the code is well structured, there's no more minimum way of putting stuff than in the code, right? So if the code is well structured, if I have a question about item X, well, X is right here in the code. That's hardly ever true in the real world, but in this case it is kind of true because I'm organizing the code as I organize my thoughts around the structure of the problem. In fact, one of the things this analysis compiler solves is that mapping of kind of the map you have of what the problem solution is with the actual code and the tools and all this other crap. All right, so do as I say, not as I do. All right, so what tests we have to show? We have to print out items. I think that's it for our first section. We got to kind of kick it now. Yeah, this was but ugly. You got three sections. So we got an EA test, that's the compiler. EAR is the reporting engine. EAR test would be the reporting engine test. And then there's an EA list. Okay. All right, so now away with the sort of administrative part. Let's just dive right into code here. Okay, so you're parsing some stuff. You're making a compiler. How do you go about doing it? And I initially wanted to do fparsec because fparsec's cool, and I really love the combinatorial parser idea. I never got it to work because I just haven't played with it that much. But I started looking at it, and I'm always pushing to keep things simple. I added several things: Loggery, Hopak, Expecto, .NET, VS Code. I've added a bunch of stuff here as part of my experiment. And at some point, you pull back and say, "Yeah, I don't know. I'll add fparsec if I need it." Life is full of trouble enough as it is, and no point in borrowing some more, which I feel kind of like that's the right choice right now. We'll see how it works out. I decided if I don't need it, I'm not going to use it. And the reason I don't need it is I don't really think I'm building an abstract syntax tree. I'm not doing this thing where you kind of wander around, which is the way compilers work. Instead, I'm just tagging things, adding things, and making them parent and children to one another, which sounds sort of the same. We'll see. I think we're good. So I decided that my first problem was actually to figure out what sorts of lines I have. The person's like notes or questions or to-do items or whatever. And I had a line type, EasyAM line type here. And this is on the wiki, by the way. The wiki page has a section for each of these with an explanation of what they are. Some sample code in there already. So anyway, I started with line types. And then I realized that once I started testing, I lost a day, by the way, a day and a half maybe with this the threading thing. But once I started testing this line type idea, I realized that, oh gee, the tests weren't working. And so I spent like, I don't know, it was a day or two, maybe been 3 or 4 days, half days, but trying to get the dang tests to work right. And this is really one of these really cool things. The tests are more important than the program. If you guys haven't figured that out, this is like major win for you for this. The whole video series is worth this one thing. The tests are more important than the code. The tests are the spec, and the tests in this case were telling me that my design was wrong. So when we talk about TDD, they say it's test-driven development. It's actually test-driven design. The tests drive out the design. So anyway, I was trying to test it, and I'm like, I can't get the test to work. What do I want back? I know what I want. I mean, I know what this thing's supposed to do. This is version 3, but yet I couldn't find the data structures to make the tests work. That's a warning sign. What it was I was trying to do two things at the same time. And the two things I was trying to do was, first of all, identify whatever commands were on the line. And then the second thing was, based on that, figure out what the line type was. So I was assuming from the outside walking in, well, I can just sort of look at each line and figure out what the line is, because as a human I could. But from the computer standpoint, it's like, oh, hang on, this is too much. I can figure out what the command is on there, and you can give me a list of what the line type might be, and then on the next step I can figure out the exact line type based on the context and other stuff. And once I figured out, I'm like, oh, okay, well, gee, that's probably why it's not working then, huh? And so then the test started coming along a lot better. Basically, there's only new item, join, namespace tag, section directive, empty line, and none. So that's what it's looking for on this first step. I did not go back and finish out all of the line types. I have most of them in there, but I don't have them all because I'm just trying to sort by command type right now. So what happens is it goes through, finds a line. Notice that we're looking at the type FSI for tokens right now. It goes through, picks up the line. I've got a big old list of regexes, and it figures out it's in order. So it figures out the first regex that hits that line that passes. Boom, that's the type command that's on there. So order is important. And also, actually, want your regex to just sort of capture the one thing and nothing else, which meant I had to have some test data that contained a bunch of junk stuff that wouldn't work. It also means there's probably going to be no perfect way of doing this the first time. As I understand it, when you build compilers, the way to do this is you give a whole bunch of sample vectors that you know work, a whole bunch of, every time it fails, you put the test in. And then over time, you become confident you've covered all your edge cases, because it's a string processing. I mean, it could continue to be whack. Of course, with a full suite of tests, then it prevents me from fixing one thing and breaking another, which was what I was doing in the old version of EasyAM, which is one of the reasons I wanted to roll back. I had tests in there, but I wasn't testing as thoroughly as I wanted. So we got the line type, where we're headed. We got the command type. That's what we're doing right now. And then to find the command type, it goes down to the regex matcher types to figure out what it matches. So what does this module do for everybody else in the world? It gets regexes for a command. So if you've got a command, say, hey, what are the regexes for? This will tell you. It'll find the first line matches, which we just talked about. It'll find first line match would be the second thing. It'll find the first command type match. It also matches the line with the recommended command. We only needed one initially here, which is just find the command type. These other ones are actually added mostly based on needing them for testing. And I'll also need them later on. So the tests are also driving out the tests are driving everything pretty much. Okay, so go to the implementation file, tokens.fs. We include a bunch of stuff here. It keeps opening stuff for me that I didn't ask to open, like the system link, and I don't know why. It's rather odd. So I comment it out when I can, and then the computer should not do things while I'm not looking. That's not from a programming sense, no good. Here are my types again. Here my logging system we talked about in the last episode. Blah, blah, blah. More type stuff, more of this type stuff. I have some helper classes, do a list. I have a try parse member for my classes. So for these tokens, one of the things I decided to do early on was to make these what I would call full-featured types. So they can do a toString, they convert themselves to a list, they try to parse themselves. These tokens are things we're going to be using a bunch of, right? And so I know this because this is version 3. So I went ahead and added the bells and whistles in because I have a feeling I want to use these tokens as if they were another language element in .NET, right? I don't want them to be a construct that I made. And we'll find out later on. I'll add iComparable and a bunch of other stuff. But right now, I just added in some basic stuff. This came in really helpful later on because even doing the tests, I could do like a toString, and it saved me a bunch of effort before we even got there, which is way cool. The try parse, actually, do you want to parse like lowercase or case sensitive? So I actually have a active pattern here. Don't do a lot of active patterns. It's just a cool concept. I don't use that much of for whatever reason. You're welcome to look at the code. It's pretty standard stuff. Active patterns are like a function that drops like almost like an infix, I believe. But it looks cool because I can actually use this case match with the initial description, and it figures out whether it needs to change the case around or not. I got toString. I do an iFormatable. We're going to see toString come back again because I'm printing this stuff out. kind of wondering how I want to print it and everything. And that would go in with the type. In this case, in most cases, no, but this is like something we use a lot of. I would want to standardize how this prints out. If I didn't want to standardize it, I would implement an iFormatable. Well, I do the format string, and it's a lot of fun. It's fun for the whole family, really. So, okay, now here we have my actual list of tokens where it finds the possible commands and line types. And I named this Gene, the line matching machine, which I felt was pretty cool for those who remember the Gong Show. And it's just a list of tokens. If you saw the data type previously, I've got the token type, like a new item. Then I've got the list of regexes that might match the new item. And like I said, order is important of all this, right? And then I've got how many capture groups to expect when I'm on the other end pulling it off. I've got the join, namespace, tag, section directive, blah, blah, blah. I mean, it's just filling in the data from before. So I've got a bunch of regexes. I'm going to throw some strings at them. This little array here is going to figure out, hey, what's the first regex matches? And it's going to say, hey, you got this command on there, and this command may give you these possible line types. That's the function of this. That's the purpose for this data structure. I've got a template data structure at the bottom here. Here's the functions implemented. Not a lot of code here. Should not be a lot of code here. Ideally, you want types that control flow and very small methods. I also added some placeholder stuff in for role information based on the domain model of learning. It actually blows out into an org model at some point if you want to do that. And so I'm kind of working on the second book, and I use the compiler as well as a tool to make sure that there's no logical errors in my reasoning. I was telling my friend Mike Feathers that I can't tell you this is right. This may be all full of crap in the book and everything, but I can tell you, dang it, it's logically consistent. So, I mean, I've gathered things from all over the place, and F# actually, through the type system, helps me keep my thoughts in order such that I'm not saying one thing in one place and something else somewhere else. So here's some role information if you're interested in role stuff. Exciting. Buckets, role silly name. We have the dork, the codependent. I think that's it for this method. Bunch of commented stuff. Okay, that's it for tokens. So the token thing just, like I said, goes in, tries to find the command, pulls up that rascal back out. If I look here, let's go ahead and walk through compiler, and then I'll go back and look at my tests, because the tests are just as much programming as the programming is. More so, in fact, since they're more important. Compiler FSI. Have my spec up top. Okay, so I had the set logger. Yeah, the logger thing was, this is fun times. I have a type that's the line identification. And so basically, what I decided to do, which I haven't really made my mind completely yet about, is that I have something called a compilation line. Okay, so that's a line of stuff running through the system. So if you do a bunch of notepad files and the compiler picks them up, it orders them by name, and then turns it into a big stream of initially just string array. But then that translates into a compilation line. And the compilation line, there's two ways of doing this. I can make it separate types, like a pre-sorted compilation line. So each little step would be a different type of compilation line. To me, that was just kind of stupid, because it's mostly the same data except for just a little bit. And so there's your case for discriminated union here. And so here I have the line identification. And so the compiler line's all the same, all this stuff, except for this type dealing. That could be either a command match, which means we found a command on it, but we don't know what line type it is. Or a line type, which means we finished processing, I know what type of line it is, along with this rest of the stuff. Why do I need the rest of the stuff? Because I know from this being version 3 again, printing messages back to the debugger, going in as a user, figuring out what I did wrong, all this stuff is needed later on. I wrote some methods here. Is compilation a file begin, a file end. What I did decide to do, I'm not sure this is also a good idea, we'll see how it works out, was if I pull like 5 lines in from a file, I'll stick a file begin at the beginning and a file end at the end, just as flags for my stream. I'm not really sure why I decided to do that. I didn't want to keep going back and checking to see if the compilation number had changed. So I just thought I'd just put it all on the stream. Maybe it's a bad idea. But anyway, when I put those flags in, now I got to say, well, is this line one of those flags? Then I also have to filter out the flags. It's already become more work than it's worth, but we'll see. I still think it's a good idea. And some more comments on what I just said. We have remove file markers from stream, remove file markers from result. And then we have the big kahuna, we have compile. It takes a compilation unit type array, which is just files and file info and a string array, and turns that into our compilation result type, which is just a big array of those lines we talked about earlier. Okay, so we're getting file, a bunch of strings, file, a whole bunch of that crap, popping it all together in one big thing, which we did last time. And then we're going through that big one big thing and decide on what the heck's in here. That's what compile does. Okay, so let's go look at the compile FS. This is whack. What to do with a logger static? Oh, yeah, ha ha ha. All right, so I started running this, and I of course ran my tests, and the dang thing. My logging system, the tests didn't work. They failed, of course, which they should. But I couldn't see what the heck was going on inside of here. And I thought about doing a debug walkthrough, and I'm like, no, hang on. This should be debuggable without the debugger, because if not, what am I going to do if it doesn't run on my site? I mean, this is all free, but if I'm using the debugger, I'm not understanding what I should understand about the code. The code's not well tested. It's just a whole bunch of bad things. I'm not saying I won't do it in the future, but not now. So what the heck's going on? Why can't I log? The logging system was broken yet again, and there's nothing wrong with the guy that wrote the logging. It's a beautiful system, love it. The problem is that this is a library. It's a shared library. It means it's a dynamic link library, DLL. It's pulled into process space by different clients who use it. By definition, it's not supposed to have stuff it keeps, right? You're supposed to have one DLL and 50 clients calling it. So it can't really have a logger that's just kind of waiting to do stuff with it. That's not the way the design of DLLs are supposed to work. And if I got this wrong, please let me know. I'm reaching back to VBX days when I say this, because I used to write custom VB controls. So I really got frustrated because I didn't know really kind of how I wanted to do this. Did I reorganize the logging system? I decided for this one file, I was going to make a method called setLogger, and it would just basically take a function that logs stuff and keep it for later, and that's what it does. You got immutable, got the little setLogger, and then it uses that function for this one file. Do I want to use this for all my files? Heck no. I just can't decide how I want to do it. I talked last time about actually pulling all the logging into the DLL and making the same kind of thing just at the whole across the board for everything. Logging would just be another library provided service. But then that links my users into my library. I'm not crazy either way. That's probably the best answer. It's a lot of work. Makes me sad. Here are my types. Here we have the implementation of these things. At first, I was putting this as a line begin, these various questions I have with the data set. I'm like, hey, this has got to be a hack. It's stupid. Then it occurs to me, I'm actually probably writing what's called lenses. And so, good time to have this discussion. There's a bunch of ways of doing this. All right. So if I were writing this in an OO format, I would probably have a collection class. The collection class would have methods that would give me latest account update or whatever. And it, almost like a query against the database, it would go to the collection class and pull things back. In functional code, classically, I would actually just have a function that stood alone, but took either that data type or even better general types and goes in and finds what I want to out of it. In functional code, the pieces in OO code, the functions go right in with the data, and then you're always kind of, do I have the right hunk of data and functions? That's solid and all that stuff, right? In FP, it's all just kind of laid out there, which will drive you nuts as an OO guy. But the beauty of that is some of this function stuff is just repetitive crap that you don't need 14 different versions of blah, blah, blah. So you just abstract that into a higher order function and you're good to go. You end up with cleaner, more succinct code using FP, I think. But part of that discussion is when I want to query a bunch of stuff, how do I do that? And it's an evolve, like so many things, FP, it's an evolving thing. Initially, you would do sort of a helper function. Past the helper function is hey, I have a function I want to use a lot. And so then you would write what's called a lens. And I have a file for lenses. And lenses is just little tokens I can call and throw it a typed data set, and it will tell me, hey, give me all the things people who have blue hats or whatever. Very cool. And then from the lenses, you would evolve to higher order functions, maybe type classes. It continues to evolve. This is the incremental type development stuff I was talking about. There's no right or wrong answer to this. As you'll see, this stuff is messy as we go along. That's good. As I organize the mess, I actually organize the type system. Most of this should all just go away, actually. Matter of fact, it may be way too complicated now than what I need, hopefully. All right, so that's lenses. Here's the spec. So we have 3 pieces. I've got the compile method. The compile method actually does the translate incoming into one stream. We talked about that. Identify the stream by command type. We're doing that. We did look at the first one last time. Then we got translate command stream into line type. A couple helper methods. And here's our translate into one stream. This adds the little markers in, changes the type. And then we have the match line to command type. And basically, there should be Gene the dance machine here somewhere. Oh, it calls back to the token method. So then it just goes through each line, calls back to the token FS method we just looked at, and then the token method looks at Gene. We don't need to see Gene here. Like I said, this is decouplable. We just talked about that, how it's all kind of separate pieces. I could set up a new compiler with a new Gene dancing machine, a new set of rules, and it would run just fine. So the rules are actually completely decoupled from the system, which is way cool. It means I could actually ship updates without having to change the code, which is what I'd like to be. That's the compiler. So this is kind of how it works. It's why it works. As you can see, all these methods are the big ones are all strongly typed. I want to do, when I'm thinking about solving a problem, I wonder what's the simplest vector transform I can do to get me closer to the answer, because that doesn't involve tests. And then I start looking at how can I change my type system to enforce that the answer is what I want, because that makes sure I can't screw up. And then I think the next one is what's the smallest amount of code I can write to make the system work, which is the classic where we come in from TDD and then we write the tests in the code. So this is the code part. I'll tell you, let's take a quick break. I'll come back. I'll show you the testing part. We'll talk about what happens in the next episode. Cool. That was fun. So let's take a look at our tests. We have the smoke test. Remember, we did we're both going to do smoke tests and the bash tests to make sure that it does the same thing from both sides, which is very fortunate because that's exactly what happened this time. I thought I was done, and the tests were running fine. I said, well, let me run the bash test one more time, and dang, they were failing. And the reason I did it both inside and outside the code was I said, well, there's an off chance that last little shell of code that spits out whatever we got will get disconnected from what it's supposed to do, and well, dang if that didn't what happened. So the bash test caught that, went in and fixed it. So smoke tests pretty much just do what we talked about. Dummy files. This is all we did this last episode. Next we have the line identification test, and this would be the stuff that we just went over with the token and the compiler stuff. Okie dokie. One of the things I'm working through is how to group the tests. Right now I've got this test list just named after the method. Translate incoming into one stream, and then I've got stuff against that. You can read all that. Testing is always important. It's even more important kind of right this particular spot where I'm standing up the structure of the compiler. And because I have a decoupled system like we talked about, where I could send in the rules and the tokens separately from the actual framework here, it's very, very important that, number one, I create some sort of minimum structure that it has to have that you can add more tokens and rules to. That's good, that's solid. And then number two, if I screwed something up, or if a future programmer were to screw something up, they could see what was going on without having to recompile the system. So when I'm done here, and my goal with any F# program really is when I'm done, I don't touch the code anymore, right? That means little code, rules-based, I mean, all the stuff we're doing is supposed to end up with a command line thing I throw stuff at that I don't have to test. That's where we're going. So I wrote this big honking thing from line 66 down to line 83, which is all around, I have this line that I think is a to-do item or whatever, right? You think it's a to-do item too? And it says, well, I thought it was a note or something. And if it's not, then it prints out for the user a very detailed description of why it was confused, what it found, and then it should give enough information that the data can be changed and the code run correctly next time without being sort of programming or digging through and finding a line number or something. Then I have the opposite method that's in 85, which is just, hey, you thought this was a user story, but no, it's really actually a question or whatever. And so I actually send the negative type in. Also gives me help. And then I just go through and test this stuff. If you remember that list of commands I had in Gene, the line matching machine, those commands are matched in order right here. I'm sorry, we've got empty line. There's empty line. Freeform text. So a new item. Whatever order Gene was in, I do it here. And it gets kind of boring doing this stuff. So some of my test data is, yes, I will have some moose. No, there are no nulls here. So I mean, it's not easy. Programmer's life. I'm trying to find another one here. Unicorns are all around us. Namespace monkey butt. You take your laughs where you can get them, folks. So there's all that data. And at the very bottom of this line identification test is this big old sample text, and it's a variable called big old sample text. And it's my gnarly version of all this stuff kind of thrown together. It's as complicated as I can make it. When I'm running into a problem, I take this, I put it in one of those online regex checkers, and I start running my regec against it to see what I'm matching. And it's a great way to like refresh your regex. I tell folks I learn regex, I use it for a project, and then I forget it. And then 2 years later, I need it again. This is like my 4th or 5th loop through. I think every time I actually remember a little more than last time. So it's coming back to me now. I think I've got everything except for look behinds. I don't know. We'll see. So that's all. That's a line identification test. That's all running. I guess I should show you that it runs. Let me show you the bash file one last time, because it did have some changes here. Like I was telling you earlier, when I went back to fix it, it's when I found all this login stuff messed up. And so as part of cleaning that up, I actually factored out the bash code so that there's a bash method that takes this input file, throws it at the program, expects this line count coming back out. If not, it prints out an error message. Not writing a bash testing system by any means. There's some great systems out there, by the way, which were recommended to me by some really cool dudes. But if I'm writing a whole full-featured bash system, I'm doing something wrong here, right? So you don't want to write systems in an OS language, not bash, not a string processing language. So yeah, I just need enough of this just to test the outside as if I were a user. It looks like I got 7 tests now. I'll go even maybe 15, 20 tests. At that point, we're done with bash. I'm doing something wrong. All right, so that's bash. Let me look at the tests. I'll show you guys. Put this down here. First, we have the reporting test, the ear test. Run that. Oh yeah, I forgot. .NET always rebuilds it whether I need it to or not. And there's nothing in here. This is the reporting module I haven't filled out yet. It says it's got to fail. It should always fail, right? We'll go up one. Then we'll go to EA test. There we go. There we go. We'll run that. Now we're running through all the tests we just went over. The line identification, the smoke tests. God dang it, we're rebuilding again. There's a command line to prevent it from rebuilding. It's part of my script. I couldn't get the script to run from here. I'm still having IDE issues, which I should not. The type systems get lost. It's a freaking mess. It is frustrating. I don't want to talk about it right now. Tools should not be like this. Beautiful tools. It sucks. Yeah, actually 20 tests, and they're all running. Ooh, yay, yay us. How about the bash? We don't need the bash stuff, right? Anything else? So that's it for the test walkthrough. Also showed you the outside stuff. So the last thing to do is what we're going to do next time. Okay, so we've got, let's review where we are. We did smash files together and do nothing. Woohoo, did that. And then we did a, can you identify, oh, I haven't shown you, dang, I haven't shown you it run, have I? Okay, hang on, hang on. That's the best part. All right. So I have this file called, where are you, file? Oh. I have this file called e3.amin, okay? And I think this may look familiar to you. Because it's just the notes we just looked at. Our project notes is our data. I just love saying that. All right, so what we want to do is just want to cat that. We're just cat that, right? We're going to cat that guy. Come here, buddy. Okay, then we're going to pipe him to .NET Run. And I want to see everything. Woo. Right. All right, so this is running. I got the logging set all the way up. So we should see a ton of different logs coming out. This is what I would look at this is what I was looking at while I was developing. Oh yeah, here we go. So at the very bottom, as you can see, I took our input file and printed out. It identified. Here's the lines. Here are the line numbers and identifying the command type, command type. And then I, as a product owner, I physically looked at this and said it looked good to me. I probably got some stuff wrong. I didn't want to automate this yet. I definitely want to automate all my acceptance tests, but this one, something about this doesn't, the structure of this doesn't feel right to me. I'll see how that turns out next time. It's the whole thing of what I want my testing, what do I want my acceptance tests to look like in executable form? And since this is our first non-unit test acceptance test, then what I really want to do is think about how I want that system to keep working and how I want it to work. Let's go back to organizing the tests again. So here the tests are all running, and if you go back up and look at the logging stuff, yeah, a bunch of stuff, all kinds of logging, and more logging. Yeah. Play with it on your own. Amuse yourselves and others. There you go. So it runs, and it does what it's supposed to do. Keep tweaking on that some more, but I really want to keep pushing forward. Remember, what we're trying to get right now is not functionality, which is weird. I'm trying to get the meta stuff, right? So I'm driving through system behavior changes, which are user stories. And the goal of these initial system behavior changes are actually to work on the meta behavior, which is how we work together, how the product owner reviews stuff, how I compile, how I do videos. That's the real, it's the real thing I'm trying to figure out, because writing code is a skill we can easily learn. Us working together and all this other stuff, that's tough. So one of the meta things I learned was that this debugging of tokens is probably the most important thing I did this last little chunk of work. The generalized version of that is it's got to be user friendly to the person putting notes in who gets an error. So it can't fail in such a way that it doesn't tell the person how to recover. That's more important than anything else, right? And so we're going to interact with one another in such a way that there are no errors that we can't easily find, hopefully. All right, so next up, let's just print some stuff out. Right? We've got sorting stuff out by command type. We've pretty much got the line type stuff in there. So let's do a, what do I have here? First, let's have some sort of canonical format. So EA, which is the file we're working on, is not a reporting system. It's EAR. EAR is the reporting system. EA just compiles stuff. So the question is, what does it compile it to? And it should be able to actually read the thing it compiles. So there has to be a canonical format of, this comes first, this comes second. Now's the time to stick that stuff in there. So come up with some standard way of writing the files. Sort or it doesn't matter, something. And we'll review that. And then this is another reason why the acceptance test feels a little early for automating. The second one is print a question list of any questions anybody might have. So this would be like some notes, maybe 2 or 3 files of notes, a few questions sprinkled here. Maybe it's a question on a user story, a question on a database table, different things like that. And then we can pull out all the questions and make a list. So those are 2 user stories. They seem very doable. I should spend more time figuring out the supplementals and the parents and all that. I have not. And then what I'm going to do offline is actually go back into the master kind of deployment. Yeah, this is what the actual system is. And fill out the notes and everything. Because this file here, which is EA2.analysis model in, this will represent the deployed product, tested deployed product. I can link from the items here back into the actual code or wherever else I want. This is a CSR system, whatever. And so this is this becomes our sort of knowledge catalog that links up all of our other tools, the behavior of the system, our work. Like I said, anything to do with building the thing would the outline of that would go in here, and it would point to other places. That's the beauty of the info ops. All right, so we've got the code going so far. We've got some stories to do next. Next time, I promise, I'm just going to do 3 or 4 hours of work, and we'll do a 20-minute video. I appreciate you guys hanging out with me so far. This is fun. It's coming along. It's I had no idea it was going to change as much the structures as it did, which is, I guess, that's the way it's supposed to be. I'm going to try to keep thinking of tougher and tougher tests to keep throwing at this. The command line thing was pretty gnarly, actually. It sounds simple, but piping stuff in and out for a .NET program on multiple target environments, not a simple thing. Turned out to be really kind of wild. This thing where I'm doing automated acceptance, user acceptance, organizing my expecto tests by user story, tagging the notes back in so I could look at, say, a certain user story here and say, hey, what tests do we have throughout all the sprints that actually did this, or did this non-functional, or whatever. Those are non-trivial things. They're doable, and it's not that the technology is difficult. So much of this stuff is like the logging thing we ran into. So much of this stuff isn't that I don't know how to do it. It's like I don't know how it should be done, right? And so there's a way it feels right. It's like, oh no, this doesn't go here. This has to go over there. I was telling my friend Bob that in my mind, I'm not some programming expert. I'm a tech coach. So much of being a good program, so much of solid and the rest of it, it's just cleaning crap up, right? Get it all organized and cleaned up. Once you're through cleaning up, usually it's pretty good code. Okay, thanks for hanging out. I'll be back. I shall return. Have a good one. Bye.